Hello everyone, my name is Mario Tiazzo and I'm the Data Analysis and Visualization Librarian here at UNB Libraries. Today, we're going to take a look at how to analyze the data in this spreadsheet to create a frequency table and to calculate various quartiles and percentiles. Here, we have a modified version of the PISA 2022 data for Hong Kong. There's a lot of data here, so for our purposes, we will just use the student immigrant background data in column W. So we go to the top of the data series, then press Control-Shift down to highlight the entire data set, Control-C to copy it, go to another sheet here, press Control-V to paste it. Great. First, we want to create the frequency table in this data series. To do that, we will need to find the unique values in the series and then calculate the number of observations for each of these unique values. We could do this manually, of course, but if we go to the bottom by pressing Control down, we see that we have almost 6,000 values. So that could take us a while. Let's instead use a few Excel formulas to do the heavy lifting for us. Control up arrow to get all the way back to the top. Our first step is that we want our data to be sorted. So we have a few options. We can sort the data mechanically by using the sort option in the home ribbon, but I prefer leaving our original data as is and use the sort formula. We do this by going next to this data series here in B2, pressing the equal sign to tell Excel that we're starting a formula, typing in the formula name, in this case sort, open the parentheses, highlight the data. So we go to the top of the data here, then we press Control-Shift down to get the entire data set, close the parentheses, press Enter. The formula default is to sort in ascending order, which is what we want. Now all our data has been sorted and we still have our original data next to it untouched. Let's tag this so that we know what we're talking about here. Great. Now that we have our data organized how we want it, let's create our frequency table. For that, we will need an instance of all the unique values in our data, as well as the ability to count all the relevant values. First, let's create our data series that encompasses all the unique values in our data set. To do that, we will use a formula that we haven't seen yet called unique. Do this by going to an empty cell, in this case D2, pressing the equal sign, typing in the formula name, unique, opening the parentheses, going to our sorted data here, top of the range is here, Control-Shift down to get the entire data set, close the parentheses. These are all the unique data values in our data set. They stand for 1, native student, 2, second generation student, 3, first generation student, 9, no response. Let's tag that so that we know what we're looking at here. Let's use the same tag as the PISA data, so let's just equal this. Terrific. If we want it to be slightly more sophisticated on the Excel front, we could also nest the sort and unique formulas together. Nesting just means combining together. We would do this by going to an empty cell. In this case, let's pick D9. Again, equal. In this case, I would type in sort, open the parentheses, then unique, open that parentheses, get our original data, Control-Shift down to get it all, close the parentheses for the unique formula, and then close the parentheses for the sort formula. And then press Enter, of course. This way, you don't need to create the second column, so it's a bit cleaner, but the end result is exactly the same. So feel free to pick the one that meets your needs. I'll just delete that now just to have one example. Okay, now that we have our unique values, let's count the number of instances they show up in our data set. To do this, we can use the count formula we've already come across, but with a twist. This one is called the COUNTIF formula. We do this by pressing the equal sign in the desired cell. In this case, let's go here, E2, typing in the formula name, COUNTIF, opening the parentheses. Notice here that this formula requires two arguments, the range and the criteria. So let's highlight the data for the range requirement. Down. And then let's press the comma to tell Excel that we are moving to our next argument, which is the criteria. And in this case, we want all the instances where the number 1 shows up. So let's highlight cell D2, which has 1 in it, to tell the formula, this is the number that we want you to find, and count it if you come across it. We can then close the parenthesis and press Enter. So this tells us that there is 3,190 instances of the number 1 in our data set. We could try to drag this formula down by going back to the active cell, and you see that there's a black square at the bottom of the cell. My white cross cursor turns into a plus sign when I approach it, and I can drag this all the way down. But if I double click on the other cells here, we quickly notice that there are relative cell references, which is the default in Excel. Relative cell references simply mean that by dragging it down, all the cells in the formula also go down with it, which is what we want for the criteria value, but is not what we want for our data set range. So let's try to fix that one in place. Let's go back to our original formula that we wanted, but now before we drag down the formula, we go into the formula itself and we put number signs to lock in the original formula. So we put a number sign in front of A to lock in the column, and we put a number sign in front of 2 to lock in the row. So now when we drag this down, it will always return A2. Alternatively, we can also press the F4 key to have the same effect. So we can now click on this coordinate and simply press F4, and now we can see that both the A and the 5908 have been locked in. Press Enter. When we drag this down now and click on the formula here, we notice that the range is locked in and the criteria moves down when we drag it down, which is what we want. We can also verify that all the values are getting picked up. So let's add up all these values by using the sum formula, SUM, open parentheses, highlight these 4 values, close parentheses, press Enter. So there are 5,907 instances in this data series. If we highlight our original data, Control-Shift down, we note that the count is also 5,907. Great. Let's go back up by pressing Control-Up arrow, and let's tag this series to provide some context. Frequency. There it is, our new frequency table. You can replicate this for any data set and create a new frequency table. Now that we've created our frequency table, let's move on to calculating quartiles, and let's select a new data series from our PISA data. In this case, let's go back and pick the math scores. Control up to get all the way back up. We notice that math is in column N. Take first instance at the very top, Control-Shift down to get the entire data series. Control-C to copy it. Let's go back to sheet 1, go to an empty row here. In this case, let's pick row H, Control-V. Now we have our data series in this sheet. So Quartiles basically chops your sorted data into 4 equal chunks to help explain how the data is constituted. So if we have 4 equal chunks, that means we slice the data 3 times. When using quartiles, we typically also include the lowest and highest values in the data set to give additional context. So we would have quartile 0, the minimum value, quartile 1, the first 25%, quartile 2, the second 25%, quartile 3, the third 25%, and quartile 4, the maximum value. To create all this, we will need to use the quartile formula. So let's go to an empty cell. Let's pick, in this case, M2. Let's press the equal sign, the name of the formula. Let's use Quartile.INC. Let's press Tab to autocomplete this. Notice that this formula also requires 2 arguments, the array and the quartile. Then let's highlight the data for the array requirements. Let's go here for the first instance and Control-Shift down to get the entire data set. Press the comma to tell Excel we are moving on to the next argument. And you can see here it gives you options. Let's pick 0 for the minimum value. Let's close the parentheses, press Enter. Great. So this tells us that the lowest value in this data set is 204.752. We could drag this formula down, but let's remember that if we do that, the relative cell references will work against us here. So let's lock in our cell range for our data. Let's go back here, click on H2 and press F4 to lock it in, and on H5908 to lock that in. Press Enter. Now we can drag the formula down, and it will always include this data set. Terrific. Now we can play around with it a little bit. Instead of quartile 0, let's put quartile 1, quartile 2, quartile 3, quartile 4. Actually, we don't need this instance right here. Great. Let's tag this series to provide some context. Let's use the same tag as the PISA data. So equals this, H1, which is math. Great. Let's also create another series to explain it. So let's call it quartile 0, 1, 2, 3, and 4. So if we were to interpret this, the first quartile in this data series encompasses numbers from 204.752 to 475.4795, and so on and so forth. Also note that quartile 0 is the minimum, quartile 4 is the maximum, and quartile 2 is the median. Now, if you want it to be slightly more sophisticated on the Excel front, you could also link the quartile tag to the quartile formula so they become dynamic. So in this case, if we go back to the formula here, and instead of hard coding 0, we remove that and we replace it with a cell reference that links to the number 0. And if we drag this formula down, you'll notice here that this reference is 4, which is exactly what we want. So the numbers haven't changed, but now if we change this number, it's dynamically linked now. So if we change this number, we know exactly that we're going to get whatever the tag says, so that there's no mismatch between the tag and the actual calculation. Okay, now that we've calculated quartiles, let's move on to calculating percentiles using the PISA math scores once again. Percentiles are basically like quartiles, but the data is chopped in 100 equal chunks instead of 4 to give us a more granular explanation of how the data is constituted. Just like quartiles, when using percentiles, we typically also include the lowest and highest values in the dataset to give additional context. To create all this, we will need to use a percentile formula. So to do this, we go to an empty space. Let's pick P2, press the equal sign, enter the name of the formula, in this case Percentile.INC. I'll press Tab to autocomplete it. Notice that this formula also requires 2 arguments, the array and K for the percentile. So let's highlight the data for the array requirement. Remember, it's the math score that we're interested in. So the top value, Control-Shift-Down to get the entire data set. Press the comma to tell Excel that we're moving on to the next argument. And let's press 0 for the percentile. Close a parenthesis, press Enter. Okay, so the 0 percentile, which is also the minimum value, is 204.752, and this matches up with our quartile calculation as well. Great. Now, just like the quartile calculation, let's lock in our data coordinates and drag down our formula. Let's go into the formula here, press F4 to lock in that range, and then we can drag it down, left click, drag down. And now we can go back into the formula and change that. So if we wanted the 25th percentile, we would type in 0.25 because the K takes a decimal number. 0.25 is equal to 25%, the 25th percentile. Press Enter. If we wanted the 50th percentile or the median, we press 0.5. If we wanted the 75th percentile, we would put 0.75. And if we wanted the maximal value, the 100th percentile, we would put 1 for 100%. Now you'll notice that the first 5 numbers are exactly the same as a quartile, which makes a lot of sense because the third quartile, for example, is the 75th percentile. So those should all match up, and they do. Great. If we wanted to have something a little bit different, we could put in here, for example, the 86th percentile, so 0.86, and then that would be the 86th percentile of this data set. So let's tag this series to provide some context. Again, let's use the same tag as PISA does, math, and let's create another series to explain it. So let's tag it percentile, and then 0, 25, 50, 75, 100, and 86. Terrific. Again, if we wanted to be slightly more sophisticated on the Excel front, we could also link the percentile tags to the percentile formula. But remember to divide by 100 in order to get a decimal number. So we could go back here, and instead of having a hard-coded 0, we would delete that, point to this cell, O2, divide that by 100, and then we could drag this down. Just like the quartiles, the numbers won't change, but now this makes it dynamic. So if we wanted to, for example, find the 45th percentile, the number would change automatically. The 97th percentile, there it is. Okay, so that should be good for now. We've learned how to create a frequency table in Excel, as well as how to calculate quartiles and percentiles of a data series. I hope that this was helpful. Thanks for watching, and I'll see you in the next video. Bye for now.